Okay, in this video, we're going to be discussing how to combine functions. Specifically, we're going to be looking for the sum, the difference, the product, and the quotient of two functions. The functions we're working with in this particular problem are f of x and g of x, which I've stated for you here. You're going to be asked to give your combined function in the most simplified form possible, and you'll be asked to also state the domain for each of those combinations. Now, for the domain of any combined functions, it is the intersection of the two original domains. So in other words, the domain for f, being that this is a polynomial, you can use all real numbers in any polynomial function. It's not a radical, nor is it a fraction, so there are no restrictions on the domain. So we say that the domain is all real numbers, and I've given you a visual here by graphing it on top of a number line. So f of x is anything from negative infinity to infinity. I've also graphed for you g of x and its domain, which again is a polynomial, just like f of x. It's not a fraction or radical, so there's no restrictions. So it also has a domain from negative infinity to infinity. So it is said that when you're trying to combine functions, whether it be through addition, subtraction, multiplication, or division, that the new domain for the combined function will be the intersection of the two original domains. We can call that the common elements, which is what intersection means, the common elements between these two sets. Or when you're looking at it visually, it would just be where they overlap. That's what they have in common, which, as you can see, is everything from negative infinity to positive infinity. All of that is the overlapping of the individual domains for f and g. Now, as we go through these answers and create these various combinations, if the combination introduces a portion of the problem that requires a restriction, then we're going to have to adjust this domain that we have just figured out is negative infinity to positive infinity. So we'll see if that happens as we go through any of the answers. Okay, the first thing we're going to be finding is the sum. And in the sum, we're just asked to add function f to function g. So as you can see above, function f is 3x squared plus 13x minus 30. And we're adding that to function g, which is just x plus 6. So all you're doing is combining like terms. You have one squared term. You have two linear terms, a 13x and a positive 1x. So combined together, that's 14x. And then for your constants, you have negative 30 and positive 6. When you combine those, you get negative 24. So this represents the sum in the most simplified form that you can possibly give it. Okay, you're also asked that once you do find this combination, to state the domain, which I've already spoken about up here and drew a picture for you so that you can see that the overlap between these two original functions is everything from negative infinity to infinity. And when I created this combination, I didn't create anything that introduces an extra restriction. In other words, you see that I combine them and there's no fractions, there's no radicals, so the domain is still the negative infinity to infinity. Okay, in part 2, you're asked to find the difference. And when you find the difference, all you have to remember is that the polynomial that you're subtracting requires switching all the signs on that polynomial. So the 3x squared plus 13x minus 30 stays the same, but then we're subtracting the x plus 6. So you might want to put a parenthesis around the polynomial that you're subtracting so you remember to switch the signs of everything that comes after the minus sign. So when we go to combine like terms, we're going to be paying attention to the negative x and the negative 6. So we have one squared term. Then we have 13x take away 1x. That's going to be 12x. So the linear terms have been combined. And then we have negative 30 combined with negative 6, and that would be negative 36. So the functions combined through subtraction is 3x squared plus 12x plus minus 36. The domain is still the same as what we calculated as what we observed, I guess you could say, for the combined functions. And we looked at the overlap, which is how you find the domain for these combined functions. And I have no new restrictions imposed by combining through subtraction. So it's still negative infinity to infinity. Moving on to the product. In the product, we're going to be looking for 3x squared plus 13x minus 30 times x plus 6. Now, because you have a smaller polynomial, I would put that in front. It'll just visually be easier to keep track of what you're multiplying. And I would put the larger polynomial, the one with more terms, in the back. You're going to be doing a sort of extended version of foiling. And you're going to take x, this first term, and you're going to multiply it by everything in the second set of parentheses. That'll be these 3 arrows on the top. And then you're going to do the same thing with the 6. You're going to multiply 6 times these same 3 terms in the second set of parentheses. So following those terms and doing all of those products, there's 6 different products that we have to do. We have x times 3x squared. Remember that when multiplying, you add the powers. So this would be 3x cubed. Then it's x times 13x. That's going to be 13x squared. Then x times negative 30. That's going to be negative 30x. Then following the upside down arrows on the bottom, this is 6 times 3 is going to be 18x squared. And then 6 times 13, that's going to be 78x. That's for that middle arrow right there. And then for that last longest arrow, that's going to be 6 times negative 30, which is negative 180. And then combine like terms. So we have a cubed term. For the squared terms, we have 13 and 18. And that's 31 on that x squared term. And you can go ahead and cancel those out so you don't combine them with anything else. Then as far as the negative 30x and the positive 78x, when you combine those, that's positive 48 on your x term. So those are combined, and then negative 180. Okay, so in finding the product, we have created 3x cubed plus 31x squared plus 48x minus 180. That domain is still the same because we have produced a polynomial with no restrictions other than what we had originally. And so that domain remains the same even for the product. And then moving to the last part, we're going to find the quotient. So f divided by g. So the f function, once again, is 3x squared plus 13x minus 30. And we're dividing that by x plus 6. Now, since they have asked you to give each answer in its most simplified form, you're going to need to factor. You have to at least try to factor. Now, I'm thinking that because there's an x plus 6 on the bottom, it's likely that one of the factors on the top is x plus 6, just because, they want to see if you can simplify. So it's worth a try. If it doesn't work out, we can always try something else. So let's say that one of these factors is x plus 6. What would that make the other factor in trying to factor this? Well, we know that when we factor, the first term times the first term should be the term up front. So that would mean that this would have to be 3x. And we can always check this by foiling to see if it's correct, to see if it indeed produces this 3x squared plus 13x minus 30. Okay, and then the back term comes from multiplying the back numbers in each of these parentheses. So if that be the case, 6 times what would be that? Negative 30, negative 5. Now let's see if this truly gives us the polynomial that we just had. When we FOIL, it's front times front. That would give us that term. The middle term, which is the trickier term, comes from a combination of things. It's partly this times this, which would be negative 5x, and partly the product that is achieved right here, which would be 18x. So negative 5x plus 18x is indeed 13x, so that works out. And then that last term, of course, is the 6 times negative 5. So that did work for the factoring. Kind of used this as a little hint of how to get it factored. And then we have x plus 6 on the bottom. So that means when simplified, when you're trying to simplify a quotient, if you find matching factors in the numerator and denominator, they cancel. So the most simplified version of this quotient, which they asked us to find, indicated by f divided by g, is 3x minus 5. Then as far as the domain goes, now we have an extra restriction just imposed by the fact that the combination is now a fraction. So now let's look at these domains individually and choose the elements that they have in common, just like we discussed at the beginning. So the domain for this polynomial, as we were discussing at the top, here I'll put the number line right here. This will be my number line with a 0 right here. This will be the domain of f, just all real numbers from negative infinity to infinity, and that's what this function is. The domain for this bottom function, being that it is now part of a denominator rather than just a polynomial, we cannot use negative 6. And by the way, I do have to really make a point here that when you're doing a quotient, even though the final answer is just a very simplistic 3x minus 5, when you go to find the domain, you're going to be finding the domain of the original quotient before simplification. Before you simplify, that's what you're going to be looking for the domain on. Okay, so the top has a domain of negative infinity to infinity. The polynomial, since it is now a denominator, you cannot use negative 6. So if I was to try and draw the domain where I'm stating that negative 6 can't be used, it would look like this. I'll draw it right up underneath the domain picture for f. So let's see, let's say negative 6 was right here. That would mean there'd be a hole right here, and it could be anything to the left of negative 6, and it could be anything to the right of negative 6. So when you look at these pictures and you look to see where they overlap, we have all of this for the domain of the g function, and we have only the numbers to the left and to the right of negative 6 for the g function. So where do they overlap? What does this pink shading have to do with the yellow shading? They have all of that in common, and they have all of this in common. However, they don't have that number in common, because on one graph, it is part of the graph, the pink number line, but on this graph, it doesn't belong to that graph. So they don't have that one number. So we have to say everything from negative infinity up to, but not including 6. There's a break in it. And then everything, pick up, in order to skip over that number, then we say everything from negative 6 to positive infinity. So the domain would look like this. The elements that are common on the pink and yellow line, negative infinity, all the way to negative 6. Jump over the negative 6 because they do not have that in common. We jump over a number that is not included using the union symbol, which means or. So anything from negative infinity to negative 6 is part of the domain, or anything from negative 6 to positive infinity. And that is your domain for the combined